Let's look at solving second-order differential equations with Laplace transforms and Mathematica. For example, using Laplace transforms, solve the initial value problem y double prime plus 36y equals 144t squared minus 144t plus 224, where y of 0 equals 0 and y prime of 0 equals 26. You know what to do. First thing we do is take the Laplace transform of each side. Now the right side can be rewritten as 144 L of t squared minus 144 L of t plus 224 L of 1. Let's rewrite the left side. To do that, to rewrite the left side, we need to know these formulas, the formulas for the Laplace transform of y, y prime, and y double prime. Okay, so the Laplace transform of y double prime is this, okay? S squared y of s minus sy of 0 minus y prime of 0. And the Laplace transform of 36y, that's just going to be 36y of s. Okay, so now we plug in y of 0 equals 0, y prime of 0 equals negative 26. Let's gather things. This is just going to be nothing, so we end up with s squared capital Y of s minus 26 plus 36 capital Y of s equals capital Y of s times s squared plus 36. Now let's look at the right side. 144 L of t squared, we can figure out what that is. So based on this formula for L of t to the n, which is valid for n equals 1, 2, 3, etc., we know that L of t squared is going to be 2 factorial over s to the 2 plus 1, in other words, s cubed. L of t is going to be 1 factorial over s squared, and it turns out that L of 1 is just 1 over s. So we plug these in for L of t squared, for L of t, and L of 1. And this is what we end up with. 144 times 2 over s cubed minus 144 times 1 over s squared plus 224 times 1 over s. In other words, 288 over s cubed minus 144 over s squared plus 224 over s. So here's what we end up with. Okay, here's our equation after doing all that math. Let's divide both sides by s squared plus 36. And then let's simplify. So we end up with 288 over s cubed, s squared plus 36, minus 144 over s squared times s squared plus 36, plus 224 over s times s squared plus 36, plus 26 over s squared plus 36. So this is great. This is dandy over here. Well, we need to use partial fractions for these first three terms on the right side. So let's go ahead and do that. We know how to do that. So 224 over s squared plus 36. We can break this into something over s plus something over s squared plus 36. So because this is first degree, we're just going to get a over s. Okay? Because s squared plus 36 is an irreducible quadratic, in other words, irreducible second degree, we're going to put on top not just b, but bs plus c. And again, because it's an irreducible quadratic. Second degree equation which can't be factored using real factors. So now we multiply both sides by s squared plus 36 times s, and we end up with s. Okay, 224 equals a times s squared plus 36 plus bs plus c all times s. The way to figure out what a, b, and c are is to plug in values for s. So in this case, we plug in s equals 0. Left side, of course, is 224. Right side, that's just going to be a times 36. And that's going to be 0 times b plus c times 0. So we just end up with 36a. So in other words, 224 equals 36a. So a is 224 over 36. In other words, 56 over 9. Now let's plug in another value for s. Let's plug in s equals 1. Okay, plug in s equals 1 and we get a times, well, we know what a is. A, again, is 56 over 9. So a is 56 over 9. S squared plus 36 is 1 plus 36. bs plus c times s, it'll be b plus c times 1. When you do the math, you end up with 2072 over 9 plus b over c, and all of that equals 224. Okay, now let's plug in s equals negative 1. Again, we know what a is, 56 over 9. This is still going to be 1 plus 36. S equals negative 1 will give us negative b plus c times negative 1. In other words, the right side is 2072 over 9 plus b minus c. So here's our system of two equations and two unknowns. Let's add these two equations together to kill off the c's. We end up with 4,144 over 9 plus 2b equals 448. In other words, 2b equals 448 minus 4144 over 9, which is negative 112 over 9. Boy, that frac feature on the TI really helps out here. Divide both sides by 2, or multiply both sides by a half, and we end up with b equals a half times negative 112 over 9. In other words, negative 56 over 9. Lastly, let's find c. We subtract the two equations, which kills off all of this stuff and the right side, so we just end up with 2c equals 0. In other words, c equals 0. So when we write 224 over s squared plus 36 using partial fractions, we end up with 56 over 9 over s minus 56s over 9 over s squared plus 36. Now let's use partial fractions on the other two terms. So let's take 288 over s cubed s squared plus 36. Let's start with this term. We would have to express that, since it's an s cubed, we would express that it's a over s cubed plus b over s squared plus c over s plus ds plus e over s squared plus 36. Holy cow, it would be incredibly tedious to find this partial fraction decomposition. Let's use Mathematica. So using Mathematica, now at my college, Mathematica is available to all students. It's available on our website, on our college website. You can download it. For Mathematica, you just enter a part, 288 over s cubed times s squared plus 36. So you type that expression and press Shift-Enter. So in other words, what you're entering looks like this. And Mathematica, in a fraction of a second, will pump out this. So 8 over s cubed minus 2 over 9s plus 2s over 9 times s squared plus 36. It's amazingly quick. Now, if you try the same thing with Wolfram Alpha, which is the free version of Mathematica that's available online, you end up with something that's not particularly helpful. I mean, this is technically true, but not particularly helpful. Look at that. I mean, I want 2s over 9 times s squared plus 36. I don't want anybody to break it into complex numbers. Come on, that's not very useful. So forget Wolfram Alpha for this. Instead, if you just enter into some search engine like Google, partial fraction calculator, something like that, you can just try this one. For example, Symbolab. You just enter partial fractions and 288 over s cubed, s squared plus 36, and it will spit out the right answer. So I'd rather use Symbolab or just some other partial fraction calculator than Wolfram Alpha, which is usually pretty good. So if we try Mathematica on the others, like negative 144 over s squared plus 36, we end up with this, negative 4 over s squared plus 4 over 36 plus s squared. And if we try it on 244 over s squared plus 36, we end up with 61 over 9s minus 61s over 9, 36 plus s squared. So let's put all the pieces together. We saw earlier that this is what y of s is. Let's replace them with this, and this, and this, based on what we saw earlier. 26 over s squared plus 36 is just 26 over s squared plus 36. Those are fine. Okay, so what we can do is we can pull some things out. We can write this as, for example, as 2/9 times 1 over s. Now you pull out the 2/9 from this expression, pull out the 56/9 from this expression and this expression, and you can combine expressions. So for example, you can combine 56/9 times 1 over s with minus 2/9 times 1 over s, and you end up with 54/9 times 1 over s. Similarly, we get minus 54/9 times s over s squared plus 36 plus 30 over s squared plus 36. And now we take the inverse Laplace transform of each side. Okay, so we end up with something that looks like this. Now, so what you can do is you can pull the 8 to the outside here. You end up with this. You can pull the 4 to the outside here. You end up with this. 54 over 9 is also known as 6. So we'll pull the 6 to the outside. Ditto with 54 over 9 here. And then we can pull the 30 to the outside here. Okay, so here's what we've got. Y of t equals this expression. Okay, we're making progress. We need to find the inverse Laplace transform of 1 over s cubed. So when you use this formula with n equals 2, well, if you use the formula, the inverse formula is going to be L inverse inverse Laplace transform of n factorial over sdn plus 1 equals t to the n. Plug in n equals 2, and you're going to get the inverse Laplace transform of 2 factorial over s to the 2 plus 1. In other words, inverse Laplace transform of 2 over s cubed, which is 2 times the inverse Laplace transform of 1 over s cubed. It's going to be t squared based on this formula here. Awesome. So 2 times the Laplace transform of 1 over s cubed is t squared. In other words, the inverse Laplace transform of 1 over s cubed is t squared over 2. Multiply both sides by 8, and you end up with 8. Inverse Laplace transform of 1 over s cubed is going to be 8t squared over 2. In other words, 4t squared. So this expression here we can just replace with 4t squared. Similarly, the inverse Laplace transform of n factorial of s to the n plus 1 is t to the n. Plug in n equals 1, and you find that the inverse Laplace transform of 1 over s squared is t, which means that this guy, minus 4 times the inverse Laplace transform of 1 over s squared, that's just going to be minus 4 times t. Okay, next we've got 6 times the inverse Laplace transform of 1 over s. We know the Laplace transform of 1 is 1 over s. Inverse Laplace transform of 1 over s is 1. So 6 times that is just going to be 6. How about this guy? 6 times the inverse Laplace transform of s over s squared plus 36. This formula comes in handy. Laplace transform of cosine kt is s over s squared plus k squared. Okay, you can see that since k squared is 36, that we want to plug in k equals 6. So Laplace transform of cosine 6t is s over s squared plus 36, which means the inverse Laplace transform of s over s squared plus 36 is cosine 6t. So we just need to multiply both sides by negative 6. And we end up with this expression. In other words, this expression here is just going to be negative 6 cosine 6t. Ooh, how about this one? Okay, 30 times the inverse Laplace transform of 1 over s squared plus 36. Again, k equals 6. Plug that into this formula, and we end up with sine of 6t equals 6 over s squared plus 36. So the inverse Laplace transform of 6 over s squared plus 36 is going to be sine 6t. Divide both sides by 6, and we end up with the inverse Laplace transform of 1 over s squared plus 36 is 1/6 sine 6t. Multiply both sides by 30, and we end up with 30 times 1/6 sine 6t. In other words, 5 sine 6t. Oh my goodness. So we put all of that together, and we end up with y of t equals this stuff. Turns out to be y of t equals 4t squared minus 4t plus 6 minus 6 cosine 6t plus 5 sine 6t. And that's it, folks. That's the answer. Totally tangential question. Totally tangential fact. Did you know that Lake Hillier, a lake in Australia, is pink? It's derived from the algae and the other microorganisms in the water.